One thing will always be sure. We interact with objects every day. We move, we touch, we sit on chairs, we throw balls. We interact. And the way we interact are defined by physics laws that have been discovered. The man that was able to define those interactions is the most famous scientist of all. I name Sir Isaac Newton. Having an IQ of 180, he created calculus while he was isolated in his home. He discovered that light was a sum of wavelengths. And his most important discovery, the laws of motion. Those laws gave us an understanding of the interaction around us and gave us the framework of the new discipline of mechanics. A man that renounced to all romantic relations to focus on physics. But today I want to talk about the laws of motion. They work with all object that has a mass. So why not a rocket? There are 3 laws that are linked with 3 words: motion, force, and acceleration. So let's define them. Motion is when an object changes position. By walking, I change position and therefore I'm in motion. A force is an action that causes change in position or change in the shape of an object. A force makes an object in motion, and if I punch a card box, it will probably deform. I applied a force to the box. The unit of a force is the Newton. An acceleration is a change of velocity over time. We often misunderstand acceleration with speed. We think that the speed that gives us the sensation of going fast, but it's really the change in velocity that we feel. We feel the takeoff of a plane while it's speeding up, but not when it's cruising at 900 kilometers per hour in the sky. Now that we define those words, let's dive in the worlds of mechanics. To explain the first law of Newton, let's imagine we are sleeping. Most of the time, when we are sleeping, we don't move and we stay at rest. Now imagine it's a Monday morning and you have to wake up for school. The alarm goes off and you wake up. The alarm made you wake up, right? Well, imagine that the alarm is a force. Until the alarm doesn't go off, you are at rest. But then, when you wake up, you are in motion. You stayed at rest until the alarm went off. The first law of Newton says, an object at rest will remain at rest until you apply a force to the object. And that works also if the object is in motion. An object will stay in motion if no force is applied to the object. And that's just the case when you are in deep space. Let's just come back for a second on our example. If you slept 10 hours that night, for example, you will be less tired and you will wake up faster than if you slept 4 hours, for example. And that's the same principle with inertia. Inertia is the tendency of an object to stay in the state he is. Assume that the hours of sleep are the mass of an object. If you have more mass, it will be much difficult to move an object than if you have less mass. That tells us that inertia is proportional to mass. And that brings us to the second law of Newton. Because it says the force equals mass times acceleration. So, the more mass, the more force you will need to apply for the same amount of acceleration. For example, Let's say we have two heavy balls, one with a mass of 10 kilograms and the other one with a mass of 20 kilograms. We want to accelerate the two objects to a velocity of 5 meters per second in 1 second. We know that acceleration is the change of speed divided by the change in time. So it gives us an acceleration of 5 divided by 1. So 5 meters per second squared. Now, what will be the force that we will need to apply on the two balls for the same acceleration? For the first one of 10 kilograms, force is equal to 10 kilograms times 5 meters per second squared, which gives us a force of 50 newtons. And for the ball of 20 kilograms, we have a force of 20 kilograms times 5 meters per second squared, which gives us 100 newtons. That means that in order to move an object twice the mass, you will need twice the force for the same amount of acceleration. By deriving the second law of Newton, we get the formula for the weight. You see, believe it or not, Earth is pulling us toward its center. That's gravity. But we have the ground to support us. But imagine you jump out of an airplane. Gravity will pull you to the ground, and it does so by accelerating your body to 9.81 meters per second. That means that the acceleration of gravity is 9.81 meters per second squared, and this we call it with a little letter G. But what does the second law of Newton say? That force is equal to mass time acceleration. Now, if we replace the acceleration with the gravitational acceleration of Earth, we get the formula F equals mg. And in that case, the force in Newton represents the force that the Earth applies on us constantly. And that force is what we call weight. Now, when someone asks your weight, do not respond with your mass in kilograms, but by telling them your weight in newtons. Obviously, those two laws apply on a rocket, but the third law of Newton is fundamental to learn how a rocket works. The third law of Newton says, to every action is an equal opposite reaction. Although it's very true for life, it takes all its sense in physics. Did you ever do skateboarding? Well, imagine you're on a skateboard at rest. Also imagine that you have a ball in your hand. Now, if you throw the ball on the back of the skateboard, strangely, you will go forward. You created a force by throwing the ball. But remember, what does the third law of Newton say? To every action, there's an equal opposite reaction. Let's come back on how we created the action force. We threw the ball, and in other words, by throwing the ball, we ejected something from a skateboard in order to go forward. In other words, when you apply a force in one direction, there is always another force in the other direction of same magnitude in newtons. Good, let's translate that to a rocket. In order to move forward a rocket, we need to throw something in the opposite way in order to create a force. And that force is what we call thrust. We need to create thrust in order to escape gravity and therefore go up. That means that the thrust generated by the rocket must be greater than its weight. That's what we call thrust to weight ratio. The way you create thrust will be discussed in a future lesson. With those laws, we are able to calculate a rocket trajectory and how it will act. It's thanks to the discoveries of Newton that you will be able to build a rocket by yourself.